Okay, so the 17, they want us to find 9p4, and the formula we're using is npr is going to be n factorial over n minus r factorial. So here, if I want 9p4, it's going to be 9 factorial over 9 minus 4 is 5 factorial. So when I go to solve this, 9 factorial is 9 times 8 times 7 times 6, and I'm just going to leave 5 times 4 times 3 times 2 times 1 is 5 factorial so that it'll cancel with the 5 factorial down there. And now all I have to do is do 9 times 8 times 7 times 6. So if I do 9 times 8 times 7 times 6, that gives me 3,024. Now most calculators will do this for you, so if you're looking on your calculator, you're usually looking for an NPR button, and usually you would hit the 9, and then the NPR button, and then the 4. So play around with that and see if you can find that answer, and that should work. That's that. So 21. To use an automated teller machine, you generally must enter a 4-digit code using digits 0 through 9. How many 4-digit codes are possible if repetition of the digits is permitted? So you have 4 digits, and for each digit, you could put a 0 through 9. So 0 through 9, that's 10 numbers, and they're allowing repetition. So 10 possibilities for the first digit, 10 possibilities for the second, 10 for the third, 10 for the fourth. Just multiply those all together, you get 10,000. So 25, this one's kind of bizarre. Some doors on cars can be opened by pressing the correct sequence of buttons. A display of 5 buttons are shown. If the same button may be pressed consecutively, how many possible ways can the 5 buttons be pressed? So you want to punch 5 buttons, and for the first punch, you can choose all 5 buttons, and since you're allowed to press the same button again, for the next one you could punch 5, 5, 5, and 5. So in the back of the book I think they wrote 5 to the 5th. So 5 raised 5. So 3, 1, 2, 5 ways to punch these buttons. So you have 5 buttons you want to push, 5 possibilities for each push. So multiply them all together, that's what they want. And for part B, they want the probability that you'll get the correct sequence. Well, there's only one correct sequence that's going to work out of the 3,125 sequences possible. So the probability of correctly opening the lock is 1 out of 3,125. That's that. So 29. She plans to enroll in 4 classes: sociology, chemistry, economics, and humanities. There are 7 sociology classes, 4 chemistry classes, 3 econ, blah, blah, blah. How many different ways can he select his 4 classes? So he has 4 classes he wants to choose. Sociology, chemistry, econ, and humanities. And there are 7 sociology classes he could choose, 4 chemistry classes, 3 econ classes, and 4 humanities classes. So this many ways to do that, this many ways to do that, and so on. Just multiply them all together. 7 times 4 times 3 times 4. You get 336 ways you could choose those classes. So, moving on to 33. If a club consists of 10 members, how many different arrangements of president, vice president, and secretary are possible? So you want to choose a president, a vice president, and a secretary. You've got 10 possibilities for your president, and then I'm guessing your vice president and your president aren't the same, so there are 9 people left over to be your vice president, and therefore 8 people left over who could be your secretary. So 10 ways to choose a president, 9 ways to choose a VP, 8 ways to choose a secretary. Multiply those all together, you get 720. So 37. An identification code consists of 3 letters followed by 4 digits. How many different codes are possible if repetition is not permitted? So you have 3 letters followed by 4 digits. And we're not allowed to repeat letters. So letters there, or anything, we're not allowed to repeat anything. So letters, 26 letters in our alphabet, so 26 possibilities for that one. We're not allowed to repeat, so 25 possibilities for the second, and 24 for the third. Back to digits, 0 through 9, that's 10 numbers, and not allowed to repeat, so 9 possibilities for the next, 8, and 7. Just multiply those all together. 10 times 9 times 8 times 7. Ooh, big number. 7, 8, 6, 2, 4, 0, 0, 0. So, excellent. And 41. We're doing 41, even though it's a 31 on the sheet, but it seemed to be in order, so I'm assuming we went 41. A license plate is to consist of 3 digits followed by 2 uppercase letters. Determine the number of different license plates if repetition of numbers and letters is permitted. So we have 3 digits and 2 letters. So digits and letters. And we're allowed to repeat. So there are 10 possibilities for each one of our digits and 26 possibilities for each letter. So just multiply those all together, 10 times 10 times 10 times 26 times 26, and you get 676,000. A telephone number consists of 7 digits with the restriction that the first digit cannot be a 0 or a 1. So you've got 7 digits, and this first guy can't be a 0 or a 1. So there are usually 10 digits possible, but now we're taking away 2 of them, so 8 possibilities for that first digit. And the rest of the digits can be whatever they like. No reason we can't repeat. So there's 10 possibilities for each one of the next digits. Multiply them all together. 8 with 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. Yep. That's good. And for part B, A, this is B. How many distinct telephone numbers are possible with 3-digit area codes preceding the 7-digit number, where the first digit of the area code is not a 0 or a 1? So you have a 3-digit area code before the 7-digit number, and the first digit of the area code can't be a 0 or a 1. So normally 10 possibilities for our digits, but now we can't be 0 or 1. So there are only 8 possibilities left. This can be anything, that can be any of the 10 digits. And then I think, I'm not sure if they still have the restriction on this one. Let me look at the answer real quick. So 45. Yeah. So there's still, the restriction in part A still applies. This guy here is also only allowed to be a 0 or 1. So 8 possibilities for him. And these guys can do whatever they want. So 10 possibilities for each one of those digits. Multiply it all together, you get 64 with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So I think that's looking good. Yep, that's good. And then for part C, with increasing use of cell phones and paging systems, our society is beginning to run blah blah blah. Ooh. Developing phone numbers that use 11 digits instead of 7. How many distinct phone numbers can be made with 11 digits, assuming that the area code remains 3 digits and the first digit of the area code and the phone number cannot be a 0 or 1. So here, area code followed by an 11 digit, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, dang. It's going to be big. And same restrictions, this guy can't be a 0 or 1, this guy can't be a 0 or 1, but these can be whatever they want. So multiplying all of that together, you get 64 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. That's a lot of digits.